Meanwhile, all of you, please write your roll numbers in the chat box so that I can save the chat link. I'm going to start my today's class with a problem. And let me give you the question first of all. And if you have not gone through my videos in the YouTube, then I think there may be some trouble for you to understand what's happening. Okay, so let's begin with this problem. It is the continuation of my previous day's class with CSE section B. There I stopped at a particular problem with that where the problem was on the basis of test of significance of single proportion. My basic logic of my basic discussion, the base level discussion will be on statistical hypothesis, but I'm actually changing my problem to something else. Today, I'm going to discuss the domain of test of significance of single mean. This is the case which I'm going to discuss and for which I'm going to first give you a problem. Okay, this is a case that I'm going to discuss in today's class. You can consider this to be the case 2. And in CSE section B, I started discussing case 1. And for this case, I'm going to use what is known as jet test, or sometimes it is called a normal test. Okay, so let's begin. The question is very simple. Question says that a sample of 900 members has a mean 3.4 centimeters and standard deviation 2.61 centimeters. Is the sample mean from a large population of mean 3.25 centimeters and standard deviation 2.61 centimeters? This is the question. And the question is very simple. And to remind you, although I told you once that a large sample is considered when the sample size is greater than 30. Such a sample is called a large sample. So obviously you can see that here the sample size is 900, and which is far bigger than the size 3, and therefore this sample can be considered to be a large sample. What is the basic objective of the question? Is it a hypothesis testing problem? The answer is yes, because in this particular case, we are actually supposed to find or test the hypothesis whether we can conclude that this particular sample of 900 members whose mean has come out to be 3.4 centimeters with some standard deviation of value 2.61 centimeters, is this particular sample, from a large population, or has it been drawn from a population which is large and whose mean is 3.25 centimeters? Can we relate this value 3.4 with the value 3.25 in some way or other? This is the question. That is what I'm going to test, and for which you have to identify what is given and what is to be found out. You have to identify that there are two types of mean which has been presented over here. Say, for example, 3.4 centimeters, this value, if you read the sentence carefully, this value is called the sample mean. It is sample mean, and we can use the symbol X bar to denote the sample mean. This standard deviation which is given over here is actually the sample standard deviation. Read the line very carefully and you will understand. Let us denote this sample standard deviation by small s. And we have been asked whether this sample has been drawn from a population with mean this. So this particular value 3.25 is the population mean. So let us use the symbol mu for it, population mean. And although these two values are same, but this value will be considered as, according to the given condition, this value will be considered as population standard deviation. Here, by default, population standard deviation has become exactly equal to the sample standard deviation. It may so happen, although it is a very ideal scenario. Now, you have to identify one another thing is that this population mean mu, which is having the value 3.25, this value has not been calculated. This has not been calculated. So how can we get such values? We can hypothesize this value. We can assume this value. So it is a hypothesized value. Okay, it is our guess. And this population standard deviation 2.61, that is also our guess. So another guessing that has been made over here is about population standard deviation, which is 2.61. Okay, so these are all guessings. We want to test our guessings on the basis of the sample which has been drawn from the respective population. Here, the population on which the problem is being done, that population's definition has not been clarified, but that will not create any trouble for us to do the problem. We can carry on with the problem. Okay, some sort of population is there whose mean has been guessed, whose standard deviation has been guessed, and we want to test the significance of this hypothesized mean of the population. So we want to test this, whether this value 3.25, this assumed value, is true or not, and therefore this particular case is called test of significance of single mean. If you have gone through my earlier videos on statistical hypothesis, you will see that the step number 1 tells us to define the two types of hypothesis. One is called null hypothesis and another is called alternative hypothesis. So here I'm going to define the null hypothesis as our population mean mu is having the value 3.25 centimeters. Okay, this is our null hypothesis. Null hypothesis is sometimes called hypothesis of no difference. Hypothesis of no difference. This is called our null hypothesis. And alternative hypothesis is population mean mu is not equal to 3.25 centimeters. Okay, every null hypothesis is associated with an alternative hypothesis. Alternative hypothesis is counter or complementary to the null hypothesis. But if alternative hypothesis comes out to be true over here, we suppose during the process we come across that this H1 is true and H0 is false, then we cannot be sure whether this population mean is less than 3.25 or it is greater than 3.25. That has not been clarified in the question. Okay, so there are two possibilities if H1 comes out to be true. These two possibilities are either mu is less than 3.25 and or mu is greater than 3.25. So since there are two possibilities in the alternative hypothesis, if it comes out to be true, such a testing is called two-tailed test. Two-tailed test. Okay, and therefore we are in the domain of a large sample two-tailed test. And I'm going to talk about how to test this null hypothesis with respect to the given information about the sample. Now let's discuss step number 2. Step number 2 says, once you design your null hypothesis, then what you want to do is that under the assumption that your null hypothesis is true, you are going to select a test statistic. You are going to select a test statistic. What is statistic? Statistic is any sample measurement. Test statistic means a sample measurement which is testing the truth of the population mean. So appropriate test statistic has to be chosen. And according to the case under consideration, the test statistic will be of this form. Since we are actually working on working with a large sample. So we are using the normal test because you already know from central limit theorem that for large sample, almost every distribution tends to follow normal distribution. And the formula that we are going to apply is the following. What is this? This is basic formula. Basic formula is x minus ex. X is the random variable and divided by standard error of x. Remember, in statistical hypothesis, all the standard deviation of x random variables will be termed as standard error of x. They are basically the same thing. The meaning of the why they are called standard error, that will be explained later on. Okay, or if you go through any statistical book, you can find in the chapter of estimation that why this is called standard error of x. Because whenever we actually call, we actually declare something about the population, every assumption is associated with some sort of marginal error, and that marginal error is characterized by standard deviation of x. And very briefly and non-mathematically speaking, the standard error of x is, because of this reason, is called standard error of x. By the way, this chapter of estimation theory is not there in your syllabus. So actually, I'm not getting into the details of that. Now, according to the current scenario, this random variable x bar will be the sample mean. This will be the sample mean x bar, which I'm denoting by small x bar. And this expectation of the random variable x, according to the present scenario, it will be x bar minus mu, and standard deviation of x will be sigma by root over n. Okay, now you see, you are actually familiar with this type of formula, which you have come across in the chapter of central limit theorem. This the formula which you are actually studied as a theorem. Now we are going to apply this as a statistical tool to test the null hypothesis. Now you see that in this formula there are 4 terms. One is x bar, another is mu, and one is sigma, and then sample size small n. All the values are actually known from the question. So x bar, the sample value is, sample mean value is 3.4. Population mean mu is 3.25 according to your assumption, and sigma is the population standard deviation, so it is 2.61. This 2.61, although the standard deviations are same, so you may think that I'm considering 2.61, which is written in the first line, but it is not. This 2.61 is the sample standard deviation, and that's 2.61 is the population standard deviation. So I'm writing here 2.61, and that will be divided by the sample size, which is 900. So you can now calculate the value of this expression. So any one of you can take the pain of calculating this value and help me out, and can write in the chat box. Please do the calculation and write in the chat box what is the value of this particular test statistic. How much value is coming? How much is coming? Can anyone say? Yeah, 1.7241 approximately. 1.7241 is the value which is coming after doing this calculation. Now, once we calculate the test statistic, we will go to the step number 3. In step number 3, it is saying that, first of all, we need to calculate the absolute value of Z. Because sometimes it may so happen that capital Z, the test statistic that we are using, is giving you the negative value. So to be on safe side, we always take the absolute value. It is because of the reason that since we are doing the normal test, and you know the normal curve is like this. So if you get the negative value, suppose some Z alpha minus Z alpha, say, actually we are going to give the conclusion on the basis of the term which is Z alpha lying on the positive side of the normal curve. So actually we are going to give our conclusion drawn upon the positive side of the normal curve. You can do the same similar kind of thing on the basis of the negative side of the normal curve. But anyways, we have to stick to one of the rules. We are sticking to the positive part. Okay, so we need to calculate this, but here the value which we have obtained is already positive. So we are writing here 1.7241. There is no change in this particular value. Step number 4 is saying that you check whether your value, the absolute value of Z, is less than 3 or it is greater than 3. Now, if this case happens, then we straightforwardly reject our null hypothesis. Okay, we do not look behind, we just reject our null hypothesis, which happened in my earlier 2 problems which I tried to do with the CSE section B. But here we are actually getting this case. Okay, and I'm going to explain now, first of all, that what happens when mod Z is less than 3. So actually when mod Z is less than 3, then we have to go for further analysis. We have to go for further analysis on the basis of a term which is called level of significance. Now in this class I'm going to explain what level of significance is once I finish this particular problem. Okay, so I'm going to explain this particular term, level of significance, but before that let me finish the problem. Now this level of significance that you have to keep in mind before we start doing the problem. We have to set our level of significance at some value. This level of significance can be set at the 0.01 or 0.01, or it can be set at the 0.05. Now, if I set at 0.01, it is called 1% level of significance. And if we set at 0.05, it is called 5% level of significance. So let us make this point over here. So the note goes like this. Before we start testing our H0, we set level of significance at the point 0.01 and or at the point 0.05. Okay, I'm writing and or. Okay, intentionally. I'll explain this particular thing. 0.01 is called 1% level of significance. And 0.05 is called 5% level of significance. Now, why have I written this word and or is because in this particular problem, nothing has been mentioned whether we need to set the level of significance at 5% or we need to set the level of significance at 1%. So what statisticians do in this particular case, they try to test the two level of significance. They try to do the two level of significance. They try to test the null hypothesis at both the level of significances. It may so happen that your hypothesis is rejected at one level of significance and being accepted at another level of significance. But if in the problem, it is mentioned specifically that what level of significance you need to take, then you have to test your hypothesis at the corresponding level of significance. Now, let us try to recapitulate what we have in our hand. So in our hand, we have point number one, we have level of significance. Suppose I'm fixing the level of significance at, suppose I'm fixing it at 0.05 or 5% level. This we have. Number two, we have a large sample. We have a large sample. The size is 900. We have two-tailed test. So these things which we have in our hand. On the basis of these three information, I'm going to test further. Now, in step number 4, I'm calling it step number 4, and I'm writing, probably you have taken the screenshot of this page. So I'm going to the next page. So what I'm going to do right now is that in step number 5, I'm going to explain how to further analyze your situation with respect to your specified level of significance. It is going like this. If you are testing H0 at 5% level of significance, and if your test is two-tailed, then reject your H0 if the absolute value of Z greater than 1.96. Accept your H0 if mod Z is less than 1.96, less than or equal to 1.96. This is the rule number 1. If you are testing H0 at 1% level of significance, and if your test is two-tailed, then reject your H0 if mod Z greater than 2.33. Accept your H0 if mod Z is less than or equal to 2.33. Okay, so these are the two values at which you are going to test your null hypothesis. So whether you are going to choose whether you are going to accept your hypothesis or reject your hypothesis, it depends upon the level of significance you are choosing and the type of test you are actually applying. Whether it is a two-tailed test or is a one-tailed test, that plays a significant role also. Here is a little bit correction. It should be this value is not 2.33, it should be 2.58, and this is called 2.58. Okay, so these are the two values that you have to keep in mind. Okay, and according to the given rule, if I try to complete my problem, then let us try to see what comes out of it. Let's get back to the problem. In our problem, we found the value of the statistic to be 1.7241, which is obviously less than 3. So that's why we said that further analysis to be needed. Now, how to draw your conclusion as per the given rule that we have set. This is my rule number 2. Okay, so my conclusion according to the given problem will be like this. I will say we have seen that the absolute value of the test statistic is less than 3, and hence H naught is retained to be tested at a specified level of significance. At a specified level of significance. And if we specify 5% level of significance, we find that mod Z, which is 1.7241, is less than 1.96. Therefore, H naught is accepted at 5% level of significance. Not only this, if you fix at 1% level of significance, you will find that 1.7241 is also less than 2.58. Because it is less than 1.96, it is also less than 2.58. And therefore, for at both level of significance, your null hypothesis is being accepted. Your null hypothesis is being accepted. And our final conclusion will be in this regard, that the given sample has indeed been chosen, from a population with mean 3.25 centimeters. Okay, so mu is equal to 3.25 is correct. This is the correct guess. So that is how we draw the conclusion according to the level of significance and the type of test that you are using. In my previous video, I only did the problem where null hypothesis got rejected because the absolute value of Z came out to be greater than 3. If it is greater than 3, then this null hypothesis is always rejected. Remember that if I draw a normal curve like this, and if I select the point -3 on the left of it and +3 on the right of it, and this is the standard normal curve, this region that I'm marking, I'm shading, this region is actually called acceptance region. This is called acceptance region. Because you see, when mod Z is less than 3, that means mathematically it means that Z is lying between -3 and +3. And the other two regions where mod Z is less than -3 or Z is greater than 3, these regions are called critical regions. Critical regions or rejection region. Critical region or rejection region. So you see that when we get mod z greater than 3, this implies there can be two cases. Either your z is less than -3 or your z is greater than +3. And therefore, in this scenario, we actually reject our null hypothesis always. But if your z is falling inside the shaded portion, black shaded portion, then we have to decide whether to consider it or reject it depending upon the level of significance specified before we start solving the problem. One another important point is that what happens when we select one tail test and a particular level of significance. So I'm going to write that case also. In another case, if we select 5% or 1% level of significance and the test is one-tailed, that means suppose I'm writing mu, as for example, I'm writing mu equal to 3.25 and mu is less than 3.25. This is my H naught and this is my H1. Or suppose I'm writing it in this manner, mu is 3.25 and mu is less than 3.25. This is sorry, not less than, greater than. So mu is greater than 3.25. This is my H naught and this is my H1. So if I write like this, so such a test is actually called two-tail test. Sorry, one-tail test. Okay, because in the first case, only left-hand side of the normal curve is considered, and in the second case, the right-hand side of the normal curve is considered. So if this is your mu, this is your mu. So if when we write mu is suppose this mu is 3.25, so when mu is greater than that, that means you are considering this, and if mu is less than that, we are considering this region. Okay, so under this circumstance, the two rules change a little bit. So rule number 1 says that if mod z is less than 1.645, I'm considering the 5% level of significance. If mod z is less than 1.645, H naught is accepted, and mod z is greater than 1.645, H naught is rejected. That is rule number 1 for one-tail test. And rule number 2 says if mod z less than 2.33, H naught is accepted, and when mod z is greater than 2. Okay, I'm putting the equality sign over here. Greater than 2.33, H naught is rejected. This happens when the test is 1%. The test is the hypothesis is tested at 1% level of significance. Okay, so this is the rule which you have to keep in mind always to test the level of significance that you have to keep in mind to test the hypothesis for testing different cases for large samples. These rules, remember that these rules which I have written over here in step number 5, these rules are universal rules. By universal rule, I actually mean that there are some other cases in hypothesis testing. In my last class, I explained about a test of significance of single proportion. Here I have discussed test of significance of single mean. Okay, and there are some other cases like test of significance of difference of means and difference of proportions. In every case, and if the sample is large, these rules defined in step number 5 will not change. They will always remain fixed. They will always remain fixed, always. Okay, and therefore, and one more thing that I want to tell you, that if when we say that 1.96 z is less than or equal to 1.96, and for which the null hypothesis is accepted, you already know that this means your z is actually lying between minus 1.96 and plus 1.96. Okay, this limit is actually called confidence limit. Confidence limit is the limit for which you accept your null hypothesis. So if 5% level of significance is actually selected, your confidence limit will become this. If 1% level of significance is selected, your confidence limit will be this. This will be your confidence limit. So level of significance and confidence limit, they are actually complementary to one another. So in the time of this particular session is running out. It is no more time is left over here. So I'm going to stop at this point. In the next session, first of all, I'm going to explain why this limit is called a confidence limit, and then I'm going to explain, if I get time, what is the meaning of this word level of significance. Okay, so let's wait for the next session to begin. And I ask all of you to, if you are using your laptop or desktop, or the laptop or desktop is in beside you and you are using your mobile phone, then also you can do it. You open my note number 8, class note 8, and where I actually shared the normal distribution note. Okay, so in that note I actually shared the normal table. So to explain the confidence limit, I have to take the help of the normal chart, and by explaining the normal chart, I can only explain this particular thing. So please open it before the next session begins.